Hello friends, today I will discuss about using of earthing transformer and construction details of the earthing transformer. It is mainly used to provide a neutral point in the system where there is no neutral point exist. For example, delta connected system. Delta connected system has no neutral point. For example, if it is a 33 kV voltage class, that is line to line voltage is 33 kV, that delta connected system has no neutral point. Now from this delta connected system, feeders are emanating from the substation. There is feeder A, feeder B and any other feeders. Now if any earth fault occur in any feeder, then there will be voltage overshoot in the other healthy phases. For example, earth fault occur in the red phase of feeder A, and therefore there will be voltage overshoot in the other phases, that is yellow and blue phases. If it is a solid earth fault, then the other healthy phases phase voltage becomes line voltage, that is phase to phase voltage is 33 kV and phase to earth voltage is 19.05 kV. If it is a solid phase to earth voltage, then yellow and blue phase voltage comes to or shoot to 33 kV. So due to earth fault in the feeder A, there will be voltage overshoot in other feeders also, and this voltage overshoot in the other healthy phases will remain until and unless the fault is cleared. So in the delta connected system, since there is no neutral point, this earth fault current has no return path. So this earth fault remain in hanging condition. So to provide a artificial neutral path or provide a ground return path for earth fault current, a earthing transformer is used. Earthing transformer is mainly used is zigzag type transformer. Now to provide a neutral point in the delta connected system, what we can use as a earthing transformer? We can use as a star delta type transformer with there is no loading in the delta side, where the star point or neutral point can be grounded to provide a return path for the earth fault current. So there exist two winding. It is a two winding transformer. There is primary winding is star connected and secondary winding is delta connected, and delta winding remain in unloaded condition. And another option is the zigzag type transformer, where the a neutral point is connected to earth. This neutral point provide the return path for the earth fault current. So in case of star delta type transformer, since two winding is used, it is more costly compared to zigzag transformer. That is why the zigzag transformer is famous for as a provide neutral path for delta connected system. That is why it is most commonly used as a earthing transformer. So the connection diagram for earthing transformer has been shown. Here each winding is divided in two equal half. That half portion of the red phase winding, that is A1, A2 and A3, A4. Similarly, half portion of the yellow phase winding, that is B1, B2 and B3, B4, and half portion of the blue phase winding, that is C1, C2 and C3, C4. Now this outer portion of the winding is called the zig winding, and this inner portion of the winding is called the zag winding. Now zig winding is connected with series of zag winding of other phases. That is, you can see that is red phase winding is connected in series with that of zag winding of yellow phase, and yellow phase of zig winding is connected in series with that of blue phase of zag winding, and blue phase of the zig winding is connected with series of red phase of the zag winding, and the other terminal are sorted together of zag winding to form the neutral and neutral is connected to earth, and the other terminal of the zag winding is connected to the system. Now here the phasor diagram has been shown. Each zig and zag winding supposed to be voltage of V by 3, where V is the line to line voltage, and the phase to neutral voltage for each phases is V by root 3. So this portion of the winding, that is each outer and inner each outer winding and inner winding has a voltage of V by 3, and the resultant voltage, that is this terminal voltage with respect to neutral, is V by root 3. This is the voltage of vector sum of this voltage and this voltage. That is why it is V by root 3. Now I will discuss about the working principle of the earthing transformer. Now consider this is the limb of a core, and in this limb two parts of the winding is connected. In the upper portion of the limb, in the upper portion of the winding, the current is flowing from left to right direction, and in the lower portion of the limb, current is flowing from the right to left direction. So due to flow of the current in the upper portion of the winding from left to right direction, the generating flux will be in the upward direction in the core. Similarly, for the lower portion of the winding, as the current is flowing from right to left direction, the generating flux will be in the downward direction. So the net flux in the core will not be zero, as this is the red phase current and this is the blue phase current. So this is the red phase current and this is the blue phase current. So there will be a time difference for red phase current and blue phase current. So net flux will not be zero in the core, but due to this connection it will create a high impedance path. Therefore, during normal condition, the earthing transformer zigzag type earthing transformer will draw only a minimum amount of current, that is the magnetizing current will be drawn from the system. Now if a single line to earth fault occur in a blue phase in the system, so the earth fault current is IF. Now we can write as per KCL, that is IA plus IB plus IC is equal to IF. That is, IF will enter in the earth and it will try to flow by the return path of the zigzag transformer and circulate towards the fault point. So IA plus IB plus IC is equal to IF. Now we can write IA, IB, IC as a sum of three sequence component of the balance component of the current. That is, IA plus is the positive sequence of the component of the current for red phase. IA minus is the negative sequence component of the current of red phase, and IA 0 is the zero sequence component of the current for red phase. Now similarly, IB equal to IB plus plus IB minus plus IB 0. Similarly, IC equal to IC plus IC minus plus IC 0. So fault current IF equal to sum of positive sequence component of current for all phases plus sum of negative sequence component of current for all phases plus sum of zero sequence component of current for all phases. Now IA plus IB plus plus IC plus is equal to 0, and IA minus IB minus plus IC minus is equal to 0. So IF is equal to IA 0 plus IB 0 plus IC 0 equal to 3I0. I0 is the equal to IA 0 plus IB 0 plus equal to IC 0. So under single line to earth fault, only zero sequence current will flow in the system. And the zero sequence component of current is in phase and equal in magnitude. So This zero sequence current enter into the earth and it will flow to the neutral point of the zigzag transformer and divide in three equal paths. That is, I0 will flow in this path to the faulted point. Similarly, I0 will flow in this path to the red phase, and I0 will flow in this path to the yellow phase to the and 2I0 flow to the faulted point, and then 2I0 plus I0 is equal to 3I0. Now, due to flow of I0 current from left to right direction in the first limb, in the outer winding or zag winding, the ampere turn produced or ampere turn will be Ni, that is the positive direction, and this is the negative direction, and flux generate will be in the upward direction in the core. Now, in the outer coil, the current will flow from right to left direction. Due to this, the ampere turn, that is Ni, will be direction of the Ni will be positive direction in direction and negative direction will be in the upward direction, and flux generated by this ampere turn will be in the downward direction. Now, this ampere turn in the lower and outer turn and the inner turn will be same in magnitude but opposite in direction, and therefore the net flux will be zero, and that is why it will produce a very low impedance path for flowing of the zero sequence current, and that is why only zero sequence current will flow in the zigzag winding, and under normal condition only a magnetizing current will be drawn from the system. So this is how the zigzag transformer works. Now, what should be the rating of the earthing transformer? Since under normal condition, the earthing transformer takes only a minimum amount of current, that is magnetizing current is drawn from the system, and under fault condition, it will provide a low impedance path for flowing of the fault current. It is and therefore it is designed for short time rating to allow the fault current for certain duration of the time, that is either for 30 seconds or 60 seconds. If it is a 60 second, then the design is such that it will be costly compared to design of the 30-second fault current carrying capacity. So it can be the rating of the earthing transformer, it can be either 551 ampere for 30 seconds or for 60 seconds. Similarly, it can be 875 ampere for 30 seconds or it can be 60 seconds. This is how the rating of the earthing transformer is rated as. So friends, if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching.